In this video, I want to talk about something that's coming up in Blender 5.0. So this is going to be just a bit of a preview of this feature, and it has to do with color management. Blender 5.0 is receiving ACES 2.0 support, and this has been causing a lot of discussion and a lot of people are happy about it. And I kind of want to show you what this is, but I also want to kind of show you why there's a great big asterisk with this that we got to talk about, because it's not entirely what people think. When we come over to the color management area, we can see that currently I have this set to standard, so there's no view transform. And when we see the view transform area, when we pop up, we can see ACES 2.0. So we first have to talk about what this means in the context of Blender's color management system. Let's quickly remind ourselves what a view transform does. Currently, I have the view transform set to standard, which means the view simply shows the rendered pixels as they are, and it does nothing to try and bring high dynamic range data into the range of 0 to 255, which a monitor can display. Now, modern monitors can actually display HDR data, and they can display a lot of colors. But traditionally, the file format that we use, let's say if you save this as JPEG format or PNG or some other format, these use a 0 to 255 color value range per RGB channel. And so the view transform has to take floating point color information, which can be very saturated and very bright, and try and bring this into what we call that closed domain 0 to 255 range. Remember, again, a ray tracer like Cycles and even Eevee can calculate color values that are way above that white point in terms of intensity. So if you don't have a view transform on, colors simply get clipped. And this is what a view transform does for us. It takes that high dynamic range data, tries to bring it down into this closed domain. Originally, Cycles had Filmic, and Filmic would take this raw information and give us that. It certainly looks better, but Filmic had a couple of problems. It had some color shift problems, and it had this particular problem called the 6 colors problem, where it would collapse a whole range of colors into just 6 basic hues when they got bright enough. So AgX came on board at 4.0 to try and fix that. And now when we turn on AgX, we get this. So it has tried to represent the brightness of those colors using just that 0 to 255 range. So algorithmically, it's been programmed to do that in a certain way. And one of the ways that AgX does that pretty successfully is by taking and progressively desaturating those very bright saturated colors until they reach white and representing those in that 0 to 255 closed domain. One of the great things that AgX does is it avoids the 6 colors problem. We can look in here and see each of these individual color bands much better than we could do that with Filmic. So from a visual standpoint, one of the things that AgX would kind of do was wash out really intense colors. And we can kind of see that on these spheres right here where they get pretty bright, they tend to lose saturation. And some people didn't like that a whole lot. Even if we came in and we applied contrasty looks, it would still tend to have that. So eventually they brought in Chronos PBR Neutral, and it would do a better job of maintaining saturation, but it's kind of a specialty view transform that's really designed to maintain color information only under neutral lighting conditions, meaning white light. So under a much more broad range of lights that could include very warm or very cool lights or HDRI lighting that's not going to be neutral, this Chronos isn't really applicable for what we're talking about here. So this is where ACES 2.0 comes in. If we come over here and turn on ACES 2.0, this is the viewport transform that we get. And notice that it gives us much better saturation in these colors. And we're still avoiding the 6 color problem for the most part, but it still does a really good job of maintaining saturation, but still giving us a sense of brightness in these colors. But there is a caveat here. And one of the things that the ACES view transform is going to do is darken up your colors and darken up your scene altogether. So this is going to be one of the key characteristics you're going to have to take into account when you're using the ACES 2.0 view transform, is your scene is going to be darker. And that darkness has come into play because they have shifted this distribution of tonality into that closed domain in such a way that it reserves higher values that are more saturated for those really bright tones that need to be brought into view. So when you're setting up a scene, you're going to need to increase the exposure, for instance. You're going to need to brighten the lights. Probably brightening the exposure is the best way to go. Here in this example, we can see this rendering is in AgX, and when we switch it over to the ACES 2.0 view transform, it's quite a bit darker. Again, remember, ACES 2.0 has been designed to shift mid-range tones into the darker range to make room for a higher range of lighter, intense colors to prevent clipping. It's a specific design choice on their part to do this. You may need to increase the exposure of your scene to take this darker tonal range into account. Let's look at two other really quick examples. Here's a scene where I have a light backlighting the scene, and it has a very strong black body of 2000, which will make it a very, very warm color. So if we come over here and we take a look at this in standard mode, you can see that it has, let me turn off all my widgets, it really struggles with this very, very bright back wall color and the intensity of that very warm black body temperature of 2000 in standard, meaning we don't have any view transform turned on. It's really hard to differentiate what's going on. So let's take a look at the old Filmic. In this case, Filmic didn't handle that actually too much better. So when we come over to AgX, AgX does a substantially better job at handling that. But now let's take a look at the ACES 2.0 view transform, and this is what we get. So this does a really great job of maintaining the color vibrancy, but also giving us a sense of the brightness. And then here's another really interesting example. This is standard view. This is no view transform. Each of these cylinders has an emitter, and in this case, the red is just a fully red color, the blue is a fully blue color, and the green is a fully green color. And in standard view, it just doesn't handle that. If we take a look at this in Filmic, Filmic kind of smoothed things out a little bit, but it's still sort of struggling. If we look at AgX, AgX does a much better job of handling the brightness and intensity of representing these colors, but it is a little bit washed out. When we come over and we take a look at this with ACES 2.0, we get that. So we get a good representation of the bright, luminous cylinders, and the saturation of the glow is really good. And let's talk a little bit for a minute about this nature of color management, because people are seeing ACES 2.0 here and they're thinking, wow, we've got the full ACES color management pipeline in place, and that's not the case. So let's talk about what's going on here in this initial implementation of ACES 2.0. So let's briefly talk about what the whole ACES pipeline is and compare that to Blender's color pipeline, because they're similar, but the differences are important. At the very heart of this color pipeline is a big pool or repository of all the colors that the color system wants to consider. Think about this for a minute. You may have an image, you may have some renders, you may have some photos or videos from a camera, and they're each going to be captured or rendered in a different color space. The camera will have a particular color profile or color characteristics. The renderer may have rendered things in sRGB, and you want to edit those all together. What ACES does is it converts all of those into a common pool of color called a color profile, and in the particular case of ACES, it's a very large color profile that encompasses a great many of the colors within the 1931 CIE chromaticity diagram. That is called an ACES CG color profile that uses what are called the AP1 primaries. The primaries are the R, G, and B colors that are defined as the endpoints of a triangle that encompasses all the colors that can be represented for that color space. Now, each of these input files is given what's called an IDT, an input device transform. And that simply is the color profile and characteristics of each of these sources. Those are then converted into the consistent color space that's used as the master editing repository of all of these colors. And this ACES CG large repository of colors and all of this source data can all be edited in a unified, consistent colorway. But then we have the issue of viewing all of that color, and you're going to be having a color station that views all of that color. And so this is where we have another part of the pipeline. In order to view that color, all of that large AP1 defined color space has to be transformed into the color space that the monitor itself is capable of displaying. And so sitting between the ACES CG AP1 color space and the monitor is an ODT, an output device transform that converts those colors into the color space that the device can display. And it's at this level where the view transform exists. In this case, the ACES 2.0 view transform sits at this location where the ODT is and the monitor that you're viewing, doing your color work on, looking into this big repository of all the color, the ACES CG AP1 defined color space. So the view transform is helping you to see inside of that world of color through the monitor and its color space. And then finally, we have another output device transform that would go to saving the file into something like a JPEG image or some other image type of format that you're going to be using. That repository of ACES CG AP1 color has to be then transformed into the output color space of the file that's transporting that image data to other devices. So that pipeline that I've just outlined is something that Blender has, but the difference between ACES and Blender is that Blender uses a more limited color space internally for all its color calculations. Internally, Blender uses Linear Rec 709 color space. This is equivalent to sRGB, and many people may find this very limiting, and in fact it is compared to the very large AP1 defined color space that ACES uses. But it is what Blender uses. And so Blender does essentially the same thing. When you import an image, you have to tell Blender what kind of image it is. Is it an sRGB defined image, or is it some other type of image that has a different color profile? Those color profiles are essentially IDTs that transform that image color space into the repository of internal color that Blender is using, the Linear Rec 709. And then when we view that on our monitor, that data then gets converted here into the display device. So even though sRGB is defined as my display device, I could change that to another one like display P3, which would actually work on my device because it supports a P3 color space. But the important thing to understand is that this right here, this display device, is what we think of as the ODT, output display transform device. And so we don't have a way through the user interface of changing the internal color repository that Blender is using to calculate everything, which again is the Linear Rec 709 color space. The view transform takes all of that data and helps us to see it on the display device that we specify here. So the ACES color pipeline and Blender's color pipeline are similar. The big difference is that ACES uses a much, much larger internal color space, which is more appropriate for studios that are going to be compositing movies and other very high definition types of output. So the important thing to note is that the ACES 2.0, as it's being integrated into version 5.0 of Blender, is a subcomponent of the total ACES color pipeline. It's simply the view transform component that has been specifically engineered to work with ACES. But it can be used in and of itself in other systems like Blender, in which case it's sitting on top of the smaller Linear Rec 709 color space. So that is the way to understand how ACES 2.0 is being used in Blender 5.0. Now, I said that you can't actually change Blender's internal color space, and that's not entirely true. The developers are not doing that right now because there's extra work that needs to be done to make the complete ACES pipeline work within Blender. But you could, if you have some engineering chops and you want to go into the OpenColor.io profile, which is just a text file, you can go ahead and configure it to use that ACES CG color space if you wanted to. My understanding again is that Blender isn't fully engineered to properly take advantage of it. No doubt somebody will come along and do that for people who want to have the proper full ACES integration within Blender. But for now, that's not going to be the case out of the box.